Hello student, in this topic you are going to learn Wheatstone bridge. The topic is Wheatstone bridge. Wheatstone bridge is the arrangement of four register in which three registers are known and one is unknown. We have to find the unknown registers in terms of three known registers. The circuit diagram drawn by Wheatstone is here. He have taken four registers in a rhombus shape. This is a 4 register. This is a galvanometer. These 4 resistors are connected across a battery source. Now let us name the resistor. This is P, this is Q, this is R and this is S. Current is I here. When current enter at point A, it is subdivided in two parts. Let this current is I1. So this is I minus I1. At B point, the current is Ig towards the galvanometer. So this is I1 minus Ig. When current enter to this point, this will be added Ig, and current from A to C is I minus Ig. So adding plus I minus I1. This current from C to D, at the same time current from B to D, this will be added up to minus Ig plus Ig cancel out, and minus I1 plus I1 cancel out. Again we have current I. So if current entering is I and current leaving is I, then this means that current labeling is correct. We have done current labeling. What is Wheatstone bridge? It is a determination of one unknown resistance in term of three known resistance. Let us put one resistance as unknown. Let R is said to be unknown. Okay. Let R is said to be unknown. Suppose you want to say it is unknown resistance, and three are known. We have to determine a equation. For that we have to first use Kirchhoff law using KVL, because Kirchhoff law is the principle on which Wheatstone bridge is working. Using KVL in loop is A, B, C, A. From when you move from A to B, you have PI1. When you move from B to C, you have G into Ig. When you go from C to A, minus sign, and R under bracket I minus I1, which is equals to 0. Now this can be written as Pi1 plus Gig is equals to R under bracket I minus I1, equation number 1. Using KVL in second loop, the naming of the loop is B, B, D, C, B. Now what we have? We have B to D. This is I1 minus Ig into Q, minus, we move to D to C, you have minus S under bracket Ig plus I minus I1. You move from C to B, you have minus Ig into G, which is equals to 0. So this can also be written as I1 minus Ig Q, which is equals to S Ig plus I minus I1 plus Ig into G, equation number 2. Now you have to divide these two equations. Dividing equation 1 by 2, you get P I1 plus Gig upon I1 minus Ig into Q is equals to R I minus I1 whole divided by S Ig plus I minus I1 plus Ig into G. Now when the wheat is balanced means galvanometer, no current will pass from B to C. It is said to be balanced condition. When the bridge is balanced, then Ig is 0. So I am writing here, when bridge is balanced, then Ig is equals to 0. So above equation become, what this equation become? Here Ig is equal to 0, so you have Pi1 in denominator side, Ig equal to 0, so you have I1 into Q. On RHS you have R I minus I1, and denominator side Ig is 0, so we have S I minus I1. We cancel this, we cancel this, we cancel this. What we get? We get P by Q is equals to R upon S. This is the equation obtained by Wheatstone, which is known as Wheatstone bridge equation. Here you can put any parameters as unknown. Suppose I am putting here R as unknown, then what will be the value of R? The value of R is equals to P upon Q into S. Since P, Q, S and R are known, so we can obtain the value of R. This is said to be Wheatstone bridge. Now let us see a question, how we used these conditions in numerical based on Wheatstone bridge. Numerical on numerical based on Wheatstone bridge. I am giving a circuit. It is a little bit complicated circuit. The circuit is, here we have a one resistance, second resistance, a third resistance, and these three resistance. Let the value of the resistance is 1 ohm, this is equals to 5 ohm, and this is equals to 4 ohm, and let another resistance will be connected between these two resistance, which is equals to 2 ohm. Let us take a resistance here which is equals to, let it be equals to 2 ohm again. Now this point is A, this point is said to be B, this is said to be C, and we have a potential source connected across it. Let the potential source is 5 volt. You have to find current I. For determining current I, we are saying that here we have a 1 ohm, 5 ohm, 2 ohm and 4 ohm. This can be drawn as, the equivalent circuit can be drawn as, here we have a resistance, here we again a resistance, this is a resistance, this is, so here we have, this is A, let it be A, so A, this be B, this is C and this is D. So resistance between A and B is 1 ohm, this is said to be 1 ohm, resistance between, this is C, this will be D, between B and C, B and, wait a minute, this is A, B, this will be C, correct, and this is D. So between B and D is 5 ohm, center part, and between D and C is 4 ohm, here this resistance BC is 2 ohm, and here this is equals to again 2 ohm. This will be the circuit which is connected across a battery having 5 volt. Then what will be happen? You have to find current. So first of all, we write P by Q, which is P. This is said to be P, this is said to be Q. So P equals to 1 ohm and Q equals to 2. Then we write here P by Q equals to R by S. This is R, this is S, this is equals to 2 by 4. So this is 1 by 2. Since P by Q is equals to R by S, valid. The condition is valid. So no current will enter from B to C. This means that the bridge is balanced. So this line will not work because no current will enter here. Now what we are saying? We are saying that these two are in series and these two are in series. So series S, series 1 is equals to 1 plus 2 equals to 3 ohm. RS series 2, this is equals to 2 plus 4, this is equal to 6 ohm. Now these two series are working as parallel. These two series are connected and this become R series 1, this become R series 2. So these are parallel. So therefore 1 by R equivalent is equals to 1 by R series 1 plus 1 by R series 2. So 1 by 3 plus 1 by 6. The LCM is 6. Here you have 2, here you have 1, here you have 3 by 6, 1 by 2. So what you get? You get R equivalent is equals to 2 ohm. Now according to Ohm's law, V equals to I into R equivalent. I into R equivalent. What is the value of V? It is 5 volt here. I, and what is the value of R equivalent? It is 2 ohm. So what is I? I equals to 2.5 ampere. Answer is 2.5 ampere. This is said to be Wheatstone bridge. Okay, thank you. Must like, subscribe and share my channel if you are understanding physics from my channel. Thank you.